Well, we're in section 7-2. And one of the things we said in 7-1 is that we're going to go from the time domain and we're going to go using Laplace transforms to the S domain where we're only going to use algebra. Well, that's probably only 95% true. So 95% of the time, that's all we're going to do. But of course, some of the algebra we're going to be using is going to be funny, naturally. And one of the things we're going to be using a lot of is partial fractions. And you probably use them in one section of your calculus book to solve particular integral problems. And you may have covered it in your Algebra 2 class in high school. So we have something that's 1 over x squared minus 1. And we say, well, that can be broken into partial fractions, x plus 1, b over x minus 1. And then we have to solve for a and b. So we do a cross multiply by x minus 1, x minus 1, and multiply by x plus 1 over x plus 1 on the other side. Normally we do this in our head, and we end up with ax minus a plus bx plus b divided by x squared minus 1. And we see that, okay, well, I need on top, this thing ax minus a, bx plus b has to equal the 1 that was on top. So I look at the x term, and I say, well, that's a plus b. I don't have any x's. Has to be 0. And then I look at the unit term, and I have minus a plus b has to equal 1. All right, well, if minus a plus b is equal, okay, so anyway, that's what we got. Do we? Yeah, minus a. Yeah, okay, so that's fine. So Kramer's rule, what is a going to be? A is going to be 0, 1, 1, 1 divided by 1 minus 1, 1, 1. And on the bottom, I've got a 2, and on the top, I have a 1. And then I do the same thing for b. And I say b, and I'm going to have 1 minus 1, and 0, 1. And I'm dividing by 2, and I end up with a half again. So, well, that can't be right. One of these guys have to be negative. What did I do wrong? 1, that's a 2. That's a 0. This is a minus. Okay, that's better. So I have minus a half and plus a half, and I add them together, I get 0. And minus a half minus, that'd be positive half, positive half, 1. So that's what I've got. So my partial fraction becomes minus a half divided by x plus 1 plus x plus 1 plus a half over x minus 1. Okay, and I say, well, what is that? Well, if this were a Laplace transform, and I had 1 over s squared minus 1, then that would be partial fractions of 1/2 minus 1 over x plus 1 plus 1 over x minus 1. And I would have, I take the inverse Laplace transform and of the whole thing. That's an s, that's an s. And I would have 1/2 e to the minus t minus e to the minus t plus e to the plus t, and I'd end up with hyperbolic sine of t. And we know that we did a Laplace transform for hyperbolic t, and we know that's 1 hyperbolic sine t, and we know that that's 1 over s squared minus 1, so that checks. And that's how we would use our partial fractions. Okay, so we look at theorem number 1. And I forget what page it's on, and we look at the Laplace transform of f of t. And we say, well, gee, that's just f of s. Okay, well, that's fine. And then we look at the Laplace transform of the first derivative. And by theorem 1, we come up with s, f of s, minus f of 0. Which means, translated into English, whenever we're doing Laplace transforms, we need initial conditions at 0. If I don't, I'm going to not be able to do what I'm going to do. We look at the Laplace transform of f double prime of t, and we end up with s squared f of s minus s f at 0 minus f at 0 f prime at 0. And plus s f of s minus f at 0 plus f of s. Okay, so we have a little bit of a pattern going on, and we're going to do the triple derivative, and Laplace transform of the third derivative of t is going to be s cubed f of s minus s squared f0 minus s f prime at 0 minus f double prime at 0. Again, I need the initial conditions at 0 to make this work, plus s squared f of s minus s f at 0 minus f prime at 0 plus s f of s minus f at 0 plus f of s. And there's a corollary to the first theorem that says I can go higher, but in general, first, second, and third is all we're going to need for this class, so that's all we're going to do. Now, breaking from my tradition of we're only going to use algebra to solve these things, we're going to ask ourselves, what if I have the integral f of t 0 to t f tau d tau, because I need a different variable for my argument than where I'm going to. I can't use t in both places. And I ask myself, well, what is the Laplace transform of that integral? And I end up with 1 over s, the Laplace transform of f of t, which is going to be f of s over s. So if I'm taking the Laplace transform of some integral, I have to start at 0. I don't have a choice. Go into something above 0. Then that's what it's going to be. And if I go the other way and say, what's the inverse Laplace transform of f of s over s, then I'm going to end up with the integral 0 to t f of tau t of d of tau. Okay, so those are just theorems that are coming out of this section of the book. Now we're going to look at problem number 2. And we're going to say, well, I've got x double prime plus 9x is equal to 0, and I've got x of 0 is 3, and x prime at 0 is 4. And I say, well, what if I'm not in this chapter? What if I'm back to doing chapter 3 stuff? Well, then I've got a characteristic equation, and it's m squared plus 9 is 0, and m is going to be plus or minus 3i, and y of x, x of whatever, x of t. And x of t is going to end up being c1 cosine t plus c2 sine t. And if x at 0 has to be 3, that implies c1 is equal to 3. And so anyway, we can solve the problem. That's the whole point. Okay. We have a 3 here, and we got a 3 there. Okay, now we're doing better. Okay, well, so x prime of t is going to be minus 9 sine 3t plus 3c2 cosine 3t, and x prime at 0 is supposed to be 4, so that implies that c2 is going to be 4 over 3, 4 over 3, and I have a final answer. X of t is equal to 3 cosine 3t plus 4 over 3 sine 3t, and I better get that same answer if I'm doing the Laplace transform, right? So that's the whole point. So now we're going to go and say the Laplace transform of x double prime plus 9x is equal to 0. Laplace transform of 0 is 0, so that's kind of cool. So I'm going to have s squared x of s minus s x at 0 minus x prime at 0 plus 9 x of s has to be 0. So that's what we have, and so we're going to have s squared and plus 9 x of s is equal to, and x of 0 is 3, so it's going to be 3s, and x prime at 0 is 4, so that's going to be 4. 3s plus 4. And x of s is 3s plus 4 divided by s squared plus 9. Okay, so that seems like a wonderful thing to do. And now I can say, well, I need to go and do something with that algebraically so that I can solve it. So x of s is going to be 3 times s over s squared plus 9 plus something over s squared plus 9. I look at I'm looking at number 8 and number 10 on my Laplace transform table, number 8 and number 10, and I look at those guys and I say, well, I need a 3 on top because this is going to be s squared plus 9 over 3. And currently I have a 4 on top, so I'm going to multiply it by 4/3 so that I can have a 3 on top. Okay, and then I'm going to go and use number 10 on that guy and number 8 on this guy, and I'm going to take a inverse Laplace transform, and I'm going to say x of t is equal to 3 cosine 3t plus 4 over 3 sine 3t, which is exactly what I had before. So I got it using chapter 3 stuff. Now I did it using Laplace transform stuff. I look in the back of the book and I see the back of the book also agrees with me. I'm happy. I'm going on to the next problem. Okay, So now I'm going to look at number 6. And I have x double prime plus 4x is equal to cosine t. And I have x of 0 is equal to something, x prime of 0 is equal to something, and they're both 0, which makes life a whole lot easier than if they're not. Okay, so I'm going to take the Laplace transform, and I'm going to get s squared x of s minus s x of 0 minus x prime at 0 plus 4 x of s is equal to, and I'm using number 10, and I got s over s squared plus 1. And I apply my initial conditions. That term is 0, this term is 0. And I end up with s squared plus 4 x of s is equal to s over s squared plus 1. Okay, and I now say that x of s is equal to s over s squared plus 4 times s squared plus 1. And now we're going to apply partial fractions to the situation. And I'm going to say x of s is equal to a s plus b over s squared plus 4. Now when you're doing partial fractions, what goes in the numerator has to be 1 less than the power of the s in the denominator. So that's why I have an a s plus b. And then I'm going to have a c s plus d over s squared plus 1. So that's what I've got. And now I'm going to go the other way. I'm going to multiply this guy by s squared plus 1 over s squared plus 1, and this guy s squared plus 4 over s squared plus 4. So I have the same numerator when I get done. Denominator? Same denominator when I have done. So I'm going to have s squared plus 4, s squared plus 1, and then on top, a s cubed b s squared a s plus b. And I'm going to have c s cubed d s squared 4cs 4d. And when I get done, what I want to have is an s over s squared plus 1, 4s squared plus 1. That's what I want. Now, the unit term, the s term, the s squared term, and the s cubed term are all linearly independent of each other. And so we use that, and we say, well, what is the s cubed term? All right, so that'd be a plus c, and it has to be 0 because there is no a cubed term. And we look at the s squared term, and that's b plus d. That also has to be 0 because there's no s squared term. We look at the s term, and we have a plus 4c, and that has to be 1 in order for me to have an s there. And then we look at the unit term, and the unit term is b plus 4d, and it has to be 0 because there is no unit term. There's only an s. Okay, so I look at those two things, and I say, okay, if b plus d is 0, and if b plus 4d is 0, then what does that strongly imply? Well, that strongly implies that b is 0 and that d is 0. Because how can it be any other way? So now that sent us from 4 equations, 4 knowns to two equations, two unknowns. So I have a plus c is 0, and I have a plus 4c is 1. And I break out Kramer's rule, and I say that a is going to be 0, 1, 1, 4. And on the bottom I got 1, 1, 1, 4. So we'll do the bottom first. 4 minus 1 is 3. And on the top I have a minus 1. So a is going to be minus a third. Okay. Okay, and if a is minus a third, then what does c have to be? C has to be a third. C has to be a third, and then I put it back in here, and I got 4 thirds minus a third is 1. Check, check, everything's fine. And now I've got my x of s is going to be minus a third s over, and I don't remember what goes there, so I have to go back and look. S squared plus 4, s squared plus 4, plus 1/3 over s. Why is there an s there? Well, because the a has an s and the c has an s. So I have to put an s there. All right. Divided by s squared plus 1. Okay, that seems reasonable. And we're going to use number 10 in both cases. But before we do that, we're going to rewrite this and say this is minus 1/3 s over s squared plus 4 plus 1/3 s over s squared plus 1. And we're using Laplace transform number 4 from our table. That's the bigger one. And we're going to take the inverse Laplace transform of both sides. And we're going to have that x of t is equal to minus 1/3 cosine 2t plus 1/3 cosine t. And we're going to go, should we check this or no? Okay, so we'll check it. So we'll do a check with back of book. The back of book agrees with us, so we'll move on. And now we're looking at number 10. X double prime plus 3x prime plus 2x is equal to t. X at 0 is 0. X prime at 0 is what? 2. Okay, and we're going to take the Laplace transform of our equation. Now this is where you don't have a 0 on the other side of the equation, so make sure when you take the Laplace transform, you do it on both sides. So I'm going to have s squared at x of s minus s f at 0 minus f prime at 0 plus 3 times s x of s minus f at 0 plus 2 x of s is equal to 1 over s. That's number 5, if anybody was wondering, number 5. Okay, and applying the initial conditions, that guy's 0, this guy's 0, and f prime of 0 would be a minus 2. Okay, so I've got s squared plus 3s plus 2 x of s. Now that I'm looking at that, s squared plus 3s plus 2, what is the characteristic equation for that guy from chapter 3? M squared plus 3m plus 2. Interesting. Anyway, back to what we're doing is equal to 1 over s plus 2. Okay, so we'll change this to 1 plus 2s over 2. 1 plus 2s over s. Yeah, you got me there. You're right, absolutely correct. This guy should be s squared. This guy should be s squared. 1 over s would be if that was a number. S squared, s squared, s squared. S cubed. S squared. S squared. All right, well, a little bit of luck, I might actually get it right. So x of s is equal to 2s squared plus 1 divided by s squared plus 3s plus 2. Isn't that cool? And we'll apply a little bit of algebra and say that that's 2s squared plus 1 divided by s squared, s plus 2, s plus 1. Okay, and then we'll do a partial fraction thing. Now, I got a square guy there, so I'm going to have to do something different. So I've got x of s is going to be equal to a over s plus b over s squared plus c over s plus 2 plus d over s plus 1. Okay, so that's what I've got. Isn't that nice? I also have not enough room to write everything down that I have to put down in order to make this thing work. And that's going to be interesting too, so we'll do our best. So now I've got that 1 plus s2s squared over s squared s plus 2s plus 1 is going to equal, I want to put everything on the same, I'm not going to have enough room to do that, am I? Yeah, well, maybe I can write small. So I've got s squared plus times s squared s plus 2, s plus 1. And then on top, what am I going to have? I'm going to have an as cubed plus 3as squared plus 2as. Okay, so these two guys multiply together times another s. So that's the s squared plus 3s plus 2 times another s. Okay, plus. Now the b guy, I've got an s squared on the bottom, so to get back I only have to put those guys up there. So that's going to just be a bs squared plus 3bs plus 2b. And at that point, I run out of room. I didn't write small enough. So what I'll do, even though I knew I was supposed to write small enough, I'll bring this guy around like that so I have enough room to continue. Okay, I've got a s plus 2 here, so I only have a s squared times s plus 1 to deal with. So I'm going to have a plus cs cubed plus cs squared. Okay, and then for that guy, I only have to deal with an s cubed plus 2s squared plus ds cubed plus 2ds squared. Okay, so I got everything where it needs to be. Now all I have to do is calculate a, b, c, and d. So I look at the s cubed term, and I see that a plus c plus d has to be 0. I look at the s squared term, and I see that 3a plus 3 plus b plus c plus 2d has to be 2 because I have a 2 in front of the s squared term. I look at the s term and I see 2a, 3b has to be 0. And then I look at the unit term and 2b, and I see that that has to be 1. Okay, so if 2b has to be 1, then b is equal to 1/2. Okay, and if b is equal to 1/2, b is 1/2, then a has to be what? A has to be minus 3/4. Because I have 3/2, I have minus 3/2, so a has to be 3/4. Well, if a is 3/4 and b is 1/2, then what do I have left over? So I have c plus d is equal to 3/4. And I have c plus 2d is equal to 15/4. Okay, so c plus 2d is going to be, I'm going to have minus 1/2, and I'm going to have plus 9/4, that's 8/4. That's, I got 2 minus 9/4 minus 1/2, 15/4. Okay. Minus 15/4, positive 15/4. Positive there, minus there. Okay, looks good. So now I know A, B, C, and D No, I don't. I don't know anything. I have 2 equations I have to solve. 2 equations, 2 unknowns. Okay, so I know A and B. I have to solve for C and D. Okay. Bring out Kramer's rule. C is going to be 3/4, 15/4, 1, 2, divided by 1, 1, 1, 2. I'll choose to do this guy first. 2 minus 1 is 1. Isn't that convenient? Okay, so I have 9/4 minus 15/4, which would give you minus 6/4. So C would be no. I have 9, I have 8 times 2. I have 6. 6 times 2 is 6. 6/4 minus 15/4, giving me minus 9/4. Okay, so if C is minus 9/4 and C plus D is equal to 3/4, then D had better be 12/4 or just a 3. Okay, so now we got to remember A is minus 3/4, B is a half, C is 3/4, D is 3. And we have to remember how they went into the equation that we had them in originally. Okay, so I'm going to have A. A is minus 3/4. So I've got x of s is equal to minus 3/4 over s plus b, which is a half, over s squared, plus 3/4 over 3/4 over s plus 2, plus 3 over s plus 1. Oh, don't need those parentheses. And C is minus 9/4, so we'll change this to minus 9/4. Minus 9/4. Isn't that convenient? Okay, I'm going to take the inverse Laplace transform of all that you see. We're going to use number 5. And we're going to use number don't remember. Maybe it's 6, I'm not sure. 6 and 7 and 7. And we're going to end up with x of t is equal to 4. Is it 4? No. Minus 3/4 plus 1/2 t minus 9/4 e to the minus 2t plus 3 e to the minus t, which we'll check. Did we check it? I'm not sure we should check it. Okay, good. Okay. Well, maybe we should check it. That would probably be a better thing to do. Okay, so I've got x of t is equal to minus 3/4 plus 1/2 t minus 9/4 e to the minus t plus 3 e to the minus, that's 2t minus t. And x of 0 is supposed to be 0, I think. Yes, x of 0 is supposed to be 0. And I've got minus 3/4 minus 9/4 plus 3, which is in fact 0, so that checks. I have x prime of t is equal to 1/2 plus 9/2 e to the minus 2t minus 3 e to the minus t, and x prime at 0 is supposed to be 2, and I've got 1/2 plus 9/4 minus 3. Okay, so 1/2 is 2/4. That's 11/4. 11/4 minus 12/4. That's not 3. What's happening here? Okay, so I got 1/2. I got, oh, this is a 2. and this is a 2. Okay, so I've got 9 halves, 10 halves, which is 5, minus 3 is 2, it checks. Well, that was convenient. Now we need x prime at t. And x prime at t is going to be minus 9 e to the minus 2t plus 3 e to the minus t. Okay, and when we got done, we want this equal to t. And we want 2 of them. We want 3 of them. And we want 1 of this guy. Okay, so I've got minus 3 halves plus 3 halves. Boom, boom, 0. I've got t. I've got t. That's all I got is t plus t. And then I've got 9 halves. 9 halves minus 9. Minus 9 halves plus 27 halves minus 9. Okay, so 27 halves minus 9 is 18 halves. I've got 27 halves minus 9 halves minus another 18 halves. So that's 0. Boom, boom, boom. Okay, I've got 6 minus 9 plus 9. So that guy's 0. Boom, boom, boom. Plus 0, plus 0. So my work checks, and I have the right answer.